In this session, we are going to discuss about time and work, which is a part of quantitative aptitude. In this topic, we are mainly supposed to establish the relationship between time and work. That is, we either need to find out the work that can be done in the given time or the time which is required to do the given work. Here, we need to consider three important variables. They are as follows. The first variable is work, which is generally denoted by W. The second one is the number of persons, which we generally denote by the letter P. And the third one is time, which in general can be taken as T. To be specific, the third variable time here can be classified into two things. That is nothing but the number of days that we can take as D and the number of hours per day that we shall denote as H. So in all, you can see we have got the variables here, that is nothing but work denoted by W, the number of persons P, number of days D, and number of hours per day H. Both the number of days and number of hours per day are units of time. Let us now discuss the first module from time and work, where the questions are based on the basic relationship between the different variables from time and work. Let us first establish the relationship between the different variables. As we have discussed earlier, we have got different variables like work denoted by W, the number of persons denoted by P, and time which is denoted by T. So let us take the relationship between these variables. Now we can say that the work done is always proportional to the number of persons doing the work if the time is constant. That means if the time is not changing, then we can say that the work is proportional to the number of persons doing the work. So when more number of persons are working together, amount of work done will be more. And when less number of persons are working, the amount of work done will be less. Or in other way, we can say that if we need to do more work, more number of persons are required at a given time. And if you want to do less work, less number of persons are required for the same time. The other relationship here is between work and time. We can say that work is proportional to time when the number of persons are constant. So when the number of persons doing the work are not changing, work is proportional to time. So for more work, more time is required, and for less work, less time is required. Which means as and when the work increases, the time required to do the work also increases. And similarly, as and when the work increases, the number of persons required will also increase. As we have already learned, the time here can be classified into two things. That is the number of days for which the work is done and the number of hours per day for which the work is done. So this can again be separated as work is proportional to the number of hours per day when the other variables are constant. That is number of persons and number of days for which you work. And similarly, work is proportional to the number of days for which you work when the number of persons and number of hours per day are constant. So if the time is classified as number of hours and number of days, then we have these three relationships. That is, work is proportional to number of persons, work is proportional to number of hours per day, and work is proportional to number of days for which you work. And when all these three are varying, we can have a combined relationship, that is nothing but work should be proportional to number of persons into number of days into number of hours per day. So as and when any of these three parameters increases, then the work done will increase. And when any of these three decreases, the work done will also decrease. Now from this proportionality between work, number of persons, number of days and number of hours per day, we can derive a very important equation. That is nothing but W1 by W2 should always be equal to P1 D1 H1 by P2 D2 H2, where 1 and 2 indicates the first and the second case respectively. So W1 is nothing but the work done in the first case, W2 is nothing but the work done in the second case. And similarly, P1 and P2 are the number of persons in the first and the second cases. D1 and D2 and H1 and H2 are the number of days and number of hours per day in the first and the second cases respectively. So from this equation, we can understand that the ratio of work done in two cases should be always equal to the ratio of the products of persons, number of days and number of hours per day. In some cases, the time is mentioned only in terms of number of days, but the number of hours are not given. So we can simply assume that W1 by W2 should be equal to P1 D1 by P2 D2. That means we neglect the terms H1 and H2. Similarly, in some cases, we find that the time is given only in terms of number of hours per day, but not in terms of number of days. So there, the equation can be taken as W1 by W2 equals to P1 H1 by P2 H2. That is, we neglect the number of days in that case. So friends, based on the variables given in the question, the equation here can be modified and the required answer can be obtained. Let us now discuss the first example based on model number 1 that we have just learned. The question here is, 15 men can type 3240 pages in 6 days, working 2 hours per day. How many men would be required to type 5400 pages, working 4 hours per day for 3 days? So here we need to find out how many men would be required to do the work in the second case. Now, as we have discussed, the work ratio, that is W1 by W2, should always be equal to the ratio of the product of persons, days and hours per day. So W1 by W2 is P1 D1 H1 by P2 D2 H2. Now, as we can see from the question here, the work here is nothing but typing the number of pages. So we can say that the work in the first case is 3240 pages. And the work in the second case here is 5400 pages. The number of persons in the first case is 15, number of days is 6 and number of hours per day is 2. The number of hours per day in the second case is 4 and number of days will be 3. So by substituting these values in this equation, we can get the required answer. So let us try to get the answer here. We know that W1 is nothing but 3240 pages. So this case is nothing but 3240 divided by W2 is nothing but 5400. So by 5400 should be equal to the number of persons in the first case is 15 men. So 15 into number of days is 6 into number of hours per day is 2. So into 2 divided by the number of persons in the second case, that is number of men has to be calculated. So let us take it as P2 into the number of days in the second case is 3 and number of hours per day in the second case is 4. So by simplifying this equation, we can find out the number of persons required in the second case. Now, zeros anyway get cancelled here. 324 is nothing but 18 into 18 and 540 is 18 into 30. So again 6 into 1 is 6, 6 into 3 is 18 and 3 into 1 is 3 and 3 into 10 is 30. So here we can say that P2 should be equal to 15 into 2 into the 10 goes on the other side divided by 3 comes in the denominator here into 4 and this 3 gets cancelled 5 times and 2 here goes 2 times and 2 into 5 is 5. So the answer here should be 25. That means we can say that 25 men are required to type 5400 pages working 4 hours per day in 3 days. Let us now take another example based on model number 1. The question here is 4 men work 12 hours daily to complete a work in 9 days. If 16 men work 2 hours daily, in how many days will the work be completed? Now the difference between this example and the previous one is, in the previous question very clearly the work was specified, that was in terms of the number of pages. But as you can see here, the work has not been specified. Remember friends, whenever in a given question the work is not specified, we can always consider the given work to be equal to 1 unit. And we can proceed with the solution with this value. So let us now see how can we get the answer for this question. We very well know that W1 by W2 should be equal to P1 D1 H1 by P2 D2 H2. Now here the question says 4 men work 12 hours daily to complete a work in 9 days. If 16 men work 2 hours daily, in how many days will the work be completed? So here he is talking about the same work to be completed. That means W1 is equal to W2. Or we can say that the work done in the second case is equal to the work done in the first case. So when W2 is equal to W1, we can very clearly understand that P2 D2 H2 should be equal to P1 D1 H1. So let us simply substitute the values of these variables and try to find out the answer. So here P2 is nothing but 16 men into D2 is to be calculated. So let us take it as D as it is, and H2 is 2 hours daily. This should be equal to P1. The number of persons in the first case is 4 into D1. The number of days in the first case is 9 into H1. The number of hours per day in the first case is 12. So by simplifying this, we can get the value of D. That is nothing but the number of days in the second case. Now, here D can be taken as 4 into 9 into 12 divided by 16 into 2. So 4 here goes 4 times. Again 4 into 1, 4 into 3 is 12. So the answer will be 9 into 3, 27 by 2. That is equal to 13.5. So we can say that the number of days required in the second case should be 13.5 days. So this is how, friends, when the work is not specified, we can always consider it to be 1 unit and proceed with the same equation. Let us now take another example from model 1 where the work done in the two cases is different. Let us look at the question here. If 15 boys can finish a piece of work in 12 days of 8 hours a day, then how long will it take for 16 boys to do a piece of work 4 by 6 as great, working 9 hours a day? So as you can see here, in the first case there are 15 boys who work for 12 days, 8 hours a day. And in the second case, we have got 16 boys here who work for 9 hours a day, and we are supposed to find out the number of days which is required to finish the piece of work 4 by 6 as grade. That means the work done in the second case is 4 by 6 times the work done in the first case. So here we can say that W2 is 4 by 6 times W1, as it is given that the work done in the second case is 4 by 6 as grade. That means 4 by 6 times the first work. Now W2 can be taken as P2 into D2 into H2. So P2 into D2 into H2 should be 4 by 6 times P1 into D1 into H1. So as simple as that. In the previous case, we have found that the work done in both the cases was same. So we took W2 equals to W1. But whenever the ratio of the works is given to us, as in this question, we can simply take W2 equals to the ratio into W1 and then substitute the given values to find out the required answer. Now we know that P2 is equal to 16 boys. So 16 into D2 has to be calculated into H2 is 9 hours a day. This should be equal to 4 by 6 into P1 is 15 boys, D1 is 12 and H1 is 8 hours a day. Now let's simplify this to find out D2. 6 into 1 and 6 into 2 gives 12. Then 2 into 8 is 16, and here on the left hand side we have got 16. So we can say that D2 should be equal to 4 into 15 divided by 9. So that is nothing but 3 into 5 and 3 into 3. So this is equal to 20 by 3. So we can say that the number of days required in the second case to do 4 by 6 as great as the previous work should be equal to 20 by 3. So as you can see from the various examples of this model, either the work done is specified in terms of number of pages, etc., or the work is given in terms of ratio. And in some cases, the work done is equal. So accordingly, we can use the equation, that is W1 by W2 equals to P1 D1 H1 by P2 D2 H2 to get the required answer. Let us now discuss the second model from time and work, where we use the concept of work done in 1 day to solve the given questions. This is also known as unitary method, where we are actually trying to find out the work done in a unit day or 1 day. So whenever we know the total work, that total work divided by number of days will give us the work done in 1 day. And this work done in 1 day can also be referred as capacity or the efficiency of the person. So the first point that we need to understand here is the capacity or efficiency. Capacity or efficiency of a person can be taken as the work done by the person in 1 day. Work done in 1 day. Now let us see how can we use this point in solving some questions. For example, let us assume that a person A can do a piece of work in A days and another person B can do the same piece of work in B days. And we are supposed to find out how much time will be required to do the work if A and B work together. So as you can see here, when A works alone, he can finish the total work in A days. When B works alone, he can finish the same work in B days. And now we are required to find out the number of days when A and B work together. For these type of questions, we simply cannot say that the answer will be A plus B days. Why? Because what we have on the left hand side is number of persons, and what we have on the right hand side here is the number of days. Number of persons and number of days are inversely related to each other. That is nothing but P is inversely proportional to D. So as the number of persons increases, the number of days required will decrease. And as the number of persons decreases, the number of days required to do the work will increase. So very clearly, the number of persons and number of days are inversely proportional to each other. And whenever two variables are inversely proportional to each other, we cannot have a direct addition on both the sides. So here, to solve this question, we need to go by the capacity of each person, or nothing but the work done by each person in one day. As I've already mentioned in the previous model, whenever the work done is not specified, it can be considered as 1 unit. So let us assume A can do 1 unit of work in A days. So the amount of work that A can do in 1 day will be equal to the total work, that is 1 divided by number of days A. So here I can say that the work done by A in 1 day will be equal to 1 by A. That is nothing but total work 1 unit divided by total number of days A. Similarly, the work done by B in 1 day will be equals to 1 by B. So here 1 by A and 1 by B is nothing but the capacity or efficiency of these persons. Right. Now when A and B work together, so when A and B are working together, we can say that the total work finished by them in 1 day will be equal to 1 by A plus 1 by B. As A can do 1 by A in 1 day and B can do 1 by B in 1 day, when both of them work together, the total which they can finish will be equal to 1 by A plus 1 by B. Now by simplifying this, we get that the LCM is AB, A goes B times and B can be taken A times. So from this equation we can understand that when A and B work together, the amount of work which they can finish in 1 day will be equal to B plus A by AB, or it can be taken as A plus B by AB. But we are supposed to find out the total number of days. Remember friends, the number of days and the work done in 1 day are reciprocal to each other, or I can say the number of days and the capacity, that is nothing but work done in 1 day, are reciprocal to each other. So we can say that the number of days should be equal to 1 by the capacity or the efficiency, or it can be taken as 1 by the work done in 1 day. So from this, very clear that the number of days should be inverse of capacity, or capacity should be inverse of number of days. So once we come to know that A and B together can finish A plus B by AB in 1 day, we can say that the number of days required when A and B work together should be equal to reciprocal of B plus A by AB. That is nothing but AB by A plus B. So this is the number of days required when two persons A and B work together. As you can see here, A alone can finish a work in A days, B alone can finish a work in B days. So the work done by A in 1 day can be taken as 1 by A, and the work done by B in 1 day is 1 by B. So when both of them work together, the total work which they can finish in 1 day will be 1 by A plus 1 by B. By simplifying that, we get A plus B by AB. But we need to find out the total number of days. Number of days is nothing but a reciprocal of the capacity. So when you take inverse of the capacity or inverse of the work done in 1 day, we get the number of days. So this can be taken as the shortcut formula. That is, if A can finish a work in A days and B can finish the same work in B days, then the total number of days required when both A and B work together will be equal to AB by A plus B. So friends, either you can use the direct formula to get the answer, or you can use the work done in 1 day to find out the total work done in 1 day and reciprocate that to get the number of days. So this is the shortcut formula, and this is the concept behind the formula there. Similarly, let us assume that there are 3 persons, A, B and C, where A can finish the work in A days, B can finish the work in B days, and C can finish the work in C days. So again, going by the capacity, we can say that the work done by A, B and C together in 1 day will be equal to 1 by A plus 1 by B plus 1 by C. This is nothing but work done by A in one day, this is work done by B in one day, and work done by C in one day. So by simplifying this, we get it as AB plus BC plus CA by ABC. So this is the work done by A, B and C in one day. But as we need the number of days, we can simply reciprocate this to get the answer. So number of days when three persons are working together can be taken as, ABC by AB plus BC plus CA. So this is the number of days required when two persons work together, and this is the number of days required when three persons work together. Similarly, if there are four persons, we can continue with the same concept and find out the number of days required. So as per your convenience, you can either use the 1 day's work or simply substitute the values in the shortcut formula to get the answer. Let us now take the first example based on model 2 that we have just discussed. The question here is A, B and C can finish a piece of work in 10, 15 and 30 days respectively. How many days will be required if A, B and C work together to finish the given work? So here, as you can see, the number of days required when A, B and C work alone are given to us. That is 10 days, 15 days and 30 days respectively. And we are supposed to find out the total number of days required when all these three persons work together. Now, as discussed in this model, we can solve the question in two ways. Either we can use the shortcut formula, that is nothing but number of days will be equal to ABC by AB plus BC plus CA, where A is the number of days taken by A, B is the number of days taken by B and C is the number of days taken by C. Or otherwise, we can go by their 1 day's work. For example, when A, B and C work together, we can say that the total work finished in 1 day will be equal to the work done by A in 1 day, which is 1 by 10. As A takes 10 days, we can say that the total work which he can do in 1 day will be 1/10 of the given work. Plus the total work done by B in 1 day should be 1 by 15. And the work done by C in 1 day should be 1 by 30. So by simplifying this, we can take 30 as the LCM here. 10 goes 3 times, 15 goes 2 times and 30 goes 1 time here. So this is equal to 6 by 30, or we can say it is 1 by 5. So 1 by 5 is nothing but the total amount of work that A, B and C can finish in 1 day when they work together. And as discussed earlier, we know that capacity is nothing but reciprocal of the number of days. So we can say number of days should be equal to 1 by the capacity, or capacity should be equal to 1 by the number of days. So by reciprocating the given capacity, we can get the answer as 5 days. So we can say that when A, B and C work together, the total number of days required will be 5. So friends, we always can find out the total capacity when the 3 persons or 4 persons are working together and simply take the inverse of that to get the number of days. Or otherwise, we can simply substitute the values in the formula to get the answer. But generally, substituting these values in the formula sometimes can become complicated. So depending on your convenience, you can either go by the formula or simply find out the amount of work done in 1 day and reciprocate that to get the total number of days. Let us now take another typical example from time and work which can be solved based on the same concept, that is 1 day's work. Let us look at the question here. B and C together can complete a work in 8 days, A and B together can complete the same work in 12 days, and A and C together can complete the same work in 16 days. So in how many days can A, B and C together finish the work? So as you can see here, we have been given the number of days required by pairs of different persons, and from which we are supposed to find out the number of days required when A, B and C together do the work. So the first statement here is B and C together can complete a work in 8 days. That means the work done by B and C in 1 day will be equal to 1 by 8. Assuming that the total work is 1 unit, B and C can finish 1 unit of work in 8 days. So in 1 day they will finish 1 by 8 of the work. Similarly, A and B together can finish the work in 12 days. So the work done by them in 1 day will be 1 by 12. And A and C can finish the same work in 16 days. So the work done by A and C in 1 day will be equal to 1 by 16. So 1 by 8, 1 by 12 and 1 by 16 are the amounts of work done by B and C, A and B and A and C respectively in 1 day each. Let us now add all these capacities to find out the total work done by all these persons here. So we can find that B plus C plus A plus B plus A plus C will be equal to 1 by 8 plus 1 by 12 plus 1 by 16. If we see here on the left hand side, we have got 2 A's, 2 B's and 2 C's. So we can say that 2 times A plus B plus C will be equal to 1 by 8 plus 1 by 12 plus 1 by 16. So let us now try to simplify this. The LCM of 8, 12 and 16 is 48. So 8 goes 6 times, 12 goes 4 times and 16 goes in 48 3 times. So this will be equal to 6 plus 4, 10 plus 3, 13 by 48. That means the work done by 2 A's, 2 B's and 2 C's is 13 by 48. But here we are supposed to find out the work done by only 1 A, 1 B and 1 C. So let us bring this 2 on the other side. So we can say that A plus B plus C in one day they can finish 13 by 2 into 48 of the work. So this is nothing but 13 by 96. So this is the total capacity of A, B and C working together. That means in one day they can finish 13 by 96 of the work. But as our interest is to find out the number of days, we need to reciprocate this to get the answer. Why? Because we have very well understood that number of days will be the reciprocal of the capacity or the reciprocal of total work done in one day. So from this we can say that number of days will be equal to 96 by 13, and this can be simplified as 7, 5 by 13. So the total number of days required when A, B and C work together will be 7, 5 by 13 days. Let us now take another example based on the concept of one day's work. The question here is 12 men can complete a work in 6 days, 8 women can do it in 12 days. If 6 men and 8 women are employed together, how many days will be required to finish the work? So as you can see here, 12 men can do a piece of work in 6 days. So we can say that 12 men can do it in 6 days. The next statement says 8 women can do it in 12 days. So 8 women, when they work together, they take 12 days to finish the work. And we are supposed to find out the number of days required when 6 men and 8 women are employed together. That means when 6 men and 8 women work together, how many days will be required? To solve this type of question, we can again go by the concept of one day's work. Here, let us assume that the group of 6 men is nothing but one person A, and this group of 8 women is one person B. Now, if we are able to find out the number of days required by the person A, or nothing but the number of days required by 6 men to do this work, and the number of days required by the person B, that is nothing but the number of days required by 8 women to do the work, then we can apply the one day's concept or the unitary method to find out the total number of days. So let us now work on to find out the number of days required by the persons A and B individually. As we can see here, person B is nothing but the group of 8 women, and we know that 8 women can finish this work in 12 days. So we can directly say that B will take 12 days to finish the work. When it comes to the person A, we have got a group of 6 men. We know that 12 men can finish the work in 6 days. Now if 12 men take 6 days, how many days will be required by 6 men? We have already discussed that persons and number of days are inversely proportional to each other. That means as the persons increases, the number of days will decrease, and as the number of persons decreases, the number of days will increase. So you can see here that 12 men have become 6 men. That is nothing but the number of men have become half. So when the number of men have become half, the number of days should get double. So we can simply say that if 12 men take 6 days, 6 men will take double these number of days. So 6 when doubled, it becomes 12 days. So we can say that 6 men or the person A will take 12 days. The other way of finding out the number of days required by 6 men would be to apply the concept of work proportional to persons into days into number of hours per day. That is nothing but model number 1. Here the number of hours are not given in the question, so that can be neglected, and we can say that work is proportional to P into D. That means W1 by W2 should be equal to P1 D1 by P2 D2, as we have discussed earlier. Now here P1 is nothing but the number of persons in the first case, that is 12 men. D1 is 6 days. P2 is the number of persons in the second case, that is 6 men, and we are supposed to find out D2, that is number of days required by 6 men. Here we can see that the work done by 12 men in 6 days is same as the work done by 6 men. So we can say that W1 is equal to W2, that is work done in both the cases is same. So when W1 is equal to W2, we very well know that P1 D1 should be equal to P2 D2. So now by substituting the values here, we can find out D2. So we know that P1 is 12 men, D1 is 6 days, P2 is 6 men, and D2 should be calculated. So we can see that 6 and 6 gets cancelled and D2 will be equal to 12 days. So this is the other way of finding out number of days required by the person A, which is 12 days as we have obtained here. But in this case, as we can see that the number of men are becoming half, directly we can say that the number of days should be double. Otherwise, when there is no direct relationship between number of men in these two cases, we can use this concept of P1 D1 equals to P2 D2 to get the number of days. So far we have obtained the number of days required by the person A, that is 12 days, and the number of days required by the person B, which is again 12 days. And we are supposed to find out the number of days required when both A and B work together. That is nothing but 6 men and 8 women work together. Now going by the 1 day's concept, we know that the work finished by A in 1 day will be 1 by 12. As he takes 12 days, in 1 day he can finish 1/12 of the work. Similarly, the work done by B in 1 day will also be 1 by 12, as B also takes 12 days. So the total work finished by A and B together in 1 day will be 1 by 12 plus 1 by 12, which is equal to 2 by 12, or it is 1 by 6. So 1 by 6 is nothing but the work done by A and B in 1 day. A and B in 1 day will be equal to 1 by 6. But we are supposed to find out the number of days required when they work together. And we know that number of days will be reciprocal of 1 day's work, or reciprocal of the capacity. So A and B's capacity is 1 by 6. So number of days should be equal to 6. That is the inverse of 1 by 6. So the answer for this question will be 6 days. That is, when A and B work together, the number of days required will be 6 days. But here in this case, we need not do the whole calculation to get the answer. You can see that A takes 12 days and B also takes 12 days. That means A and B are of equal capacity, because the work which A can finish in 12 days can also be finished by B in the same number of days. So whenever the number of days taken by the two persons are equal, when they work together, the number of days will become half. That is, when A takes 12 days and B also takes 12 days, and when they work together, the number of days should be half of 12, which is 6 days. So this whole calculation actually is not required for this particular question. Why? Because whenever two persons of equal capacity are working together, the number of days required will be simply half of the number of days taken by each one of them. For example, let us assume that A can finish a piece of work in 10 days and B can also do the same work in 10 days. So when both A and B work together, the number of days should be 5. That is nothing but half of 10. So A and B together can finish in 5 days. So similarly, in this case, we can directly say that the number of days will be 6 days. Otherwise, in cases where number of days are not equal, we can go by the 1 day's concept or the shortcut formula, that is AB by A plus B, to get the answer. Let us now discuss the most important concept from time and work, that is nothing but measurement of work. With the help of this concept, we can solve almost all the questions from time and work. Let us understand what is it all about. Measurement of work. Remember friends, work can always be measured in terms of men into days. For example, the work done can be taken as number of men doing the work into the number of days for which they work. Or similarly, we can say that the work can be taken as number of men into number of hours for which they work. That is nothing but work in general can always be taken as men into the time for which they work. For example, let us assume that 12 men can finish a piece of work in 4 days. So here the work which is done has not been specified, but we can measure the given work as number of men into number of days. So 12 men, they work for 4 days. So here the work done will be 48 men days. So the work can be taken as 48 men days. Now suppose, let us assume that 6 men have to finish the work. So how many days will be required? We know that the total work done is 48 men days. So 48 men days should be equal to 6 men are going to work. So how many days will be required? So we should try to balance the amount of work on both the sides. So 6 into 8 is equal to 48. So we can say that when 6 men do the work, 8 days will be required to finish it. Similarly, let us assume that 4 men work. So how many days will be required? Now we know that 48 is nothing but 4 into 12. So when 4 men work, 12 days are required. Likewise, when 2 men work, the number of days required will be equal to what? So we can say that for 2 men, 24 days will be required. Why? Because 48 is 2 into 24. So this is how we can use the concept of work in terms of men into days. Let us now take an example based on the concept that we have just discussed. That is nothing but measurement of work in terms of men into days. Now the question here is, a work is started by 15 people. After 5 days, 5 more people accompanied them to finish the work in next 10 days. How many people should have started the work to finish it in 11 days? So as you can see here, initially there were only 15 people doing the work. But after 5 days, 5 more people joined them to finish the work in next 10 days. So very clearly, for the first 5 days, there were only 15 people working on that. And after 5 days, 5 more people have joined. That means 15 people were already there and 5 more have joined. So now there are total 20 people working on it after 5 days. And they could finish the work in the next 10 days. So we are supposed to find out how many people should have initially started the work so that they can finish it in 11 days altogether. So let us see how can we use the concept of men into days to solve this question. Now the only thing which we need to do here is balance the total work on both the sides in terms of men into days. For example, the work was started by 15 people and we know that they have worked for 5 days. There were no changes for the first 5 days. So we can say that the work done in the first 5 days will be 15 men into 5. 15 people into 5. After 5 days, 5 more people accompanied them to finish the work in next 10 days. So after finishing this much of work, that is 15 into 5 men days, the remaining work was finished by 15 plus 5 people in the next 10 days. So this is the total work which has been finished. Let us understand this once again. For the first 5 days, there were only 15 people working. So the amount of work which they have finished is 15 people into 5 or 15 men into 5 days. So this is the total work finished in the first 5 days. After 5 days, 5 more people have joined them. So total men which are available are 15 plus 5. So 20 men, and they could finish the remaining work in 10 days. So 20 men in 10 days. And after these 10 days, the total work has been finished. So this is nothing but the total work which was done by these people. Now the question is, how many people should have started the work to finish it in 11 days? So the same work has to be finished. So this can be balanced as, let us assume the number of people which are required to finish the work in 11 days is P. So P persons in 11 days. As these persons together finish the total work in 11 days. So by simplifying this, we can get the answer for this question. So 15 into 5 is 75 plus 15 plus 5. 20 into 10 is 200. Should be equal to P into 11. So from this, P will be equal to 75 plus 200 is 275. Divided by 11 will give the answer as 25. So we can say that 25 people are required to finish the work in 11 days. If you want to justify this, you can simply check the answer by balancing the units on both the sides. 15 into 5 is 75. 20 into 10 is 200. So total work which was finished was 275 man days. And here 25 people in 11 days, 25 into 11 is also 275. So 275 man days of the work has been finished by 25 people into 11 days. Let us now take up another example from time and work which can also be solved based on the concept of work in terms of men into days. The question here is, 24 men can complete a work in 16 days. The same work can be completed by 8 women in 72 days, whereas 24 children take 32 days to complete it. If 10 men, 15 women and 24 children work together, in how many days can the work be completed? So as given in the question, 24 men can complete the work in 16 days. So we can say that the total work will be equal to 24 men into 16 days, as the work can always be measured in terms of men into days or persons into days. So 24 men into 16 days. Then the next statement here is the same work can be completed by 8 women in 72 days. That means the same work, the total amount of work here is 8 women into 72 days. So this will be equal to 8 women and they can finish it in 72 days. Whereas 24 children take 32 days to complete it. So that means again the same work can be finished by 24 children in 32 days. So this can be equated to 24 children into 32 days. And the question is, if 10 men, 15 women and 24 children work together, in how many days can the work be completed? So we need to find out the number of days required when 10 men and 15 women and 24 children work together. Let us assume that the number of days required by this group altogether will be D days. So these many persons into the number of days, D, will be the total work. So again, this can be equated to the total work in all the previous cases. So as you can see here, we have formed different equations from the given question. That is nothing but the total work is 24 men into 16 days, or it can be taken as 8 women into 72 days, or 24 children into 32 days. And we need to find out the number of days required when 10 men, 15 women and 24 children work together. Now to solve this question, what we need to do here is, in this group, we have to convert the women and children in terms of men, or the men and children in terms of women, or men and women in terms of children. That is nothing but we'll try to completely convert this group into only one type of person, that is either men or women or children, so that the solution can be obtained in a simple manner. And for that to do, we should first get the relationship between the different types of persons. Let us convert this group only in terms of men. So from this we can say that 24 men into 16 days is equal to 8 women into 72 days. So 24 men into 16 should be equal to 8 women into 72. Let us try to simplify this. We can say that 24 into 1 and 24 into 3 gets cancelled here, and 8 into 1 and 8 into 2 is 16. So we can say that one man will be equal to 3 women by 2. Or from this we can say one woman equals to 2 men by 3, or 2/3 of a man. So this is nothing but the capacity of one woman is 2/3 of the capacity of a man. So this is the conversion of women in terms of men. Let us now try to convert the children in terms of men. We know that 24 men into 16 is equals to 24 children into 32. So we can say that 24 men into 16 days is the total work. That is again equal to 24 children into 32 days. So from this, 24 and 24 gets cancelled, and 16 here goes 2 times. So we can say that one child will be equal to 1 by 2 men, or the capacity of one child is half of the capacity of a man. Let us now substitute these relationships in the given group. So we find that 10 men are men as it is. 15 women can be taken as 15 into, we know that one woman is equal to 2/3 of a man. So 2 by 3 into man, plus 24 children. We know that one child's capacity is half of a man's capacity. So 24 children can be taken as simply 24 into one child is 1 by 2 men. So this is the total group only in terms of men, and this should be multiplied with the number of days. That is nothing but total work. Now we can equate this part with the number of men into number of days. That is nothing but 24 men into 16 days. So as you can see here, on both the sides we have got the groups only in terms of men. By simplifying this, we get 3 into 1, 3 into 5, and this is 2 1s and 2 12s. So 10 men plus 5 into 2, again with 10 men plus 12 men into the number of days should be equal to 24 men into 16. So 10 plus 10 is 20, 20 plus 12 is 32. So 32 men into the number of days D should be equal to 24 men into 16. So 16 goes 32 times. We can say that the number of days required will be 24 by 2, which is equals to 12. So the answer for this question will be 12 days. So as you can see here, the simple way to solve this question is first to equate the total work in terms of men into days, women into days and children into days. Then we can find out the relationship between different types of persons, and then the given group is converted either only in terms of men or women or children. And then the total work again can be equated with a similar type of person on the other side, and we can find out the number of days required. Let us now discuss the third example from model 3, which can also be solved with the help of men into days concept. Let us look at the question first. 12 men and 18 women can complete a work in 6 days, whereas 12 women can complete the work in 18 days. 4 days after they started the work, 4 men left. How many days will the remaining people take to complete the remaining work? So as given in the question, 12 men and 18 women together can finish a work in 6 days. So going by the concept of work in terms of men into days, we can say that 12 men plus 18 women. We are taking plus because they are working together. So these persons into the number of days, 6, should be equal to the total work. And 12 women can finish it in 18 days. So this can be equated to 12 women into 18 days. Why? Because this is the total work done with men and women together, and here we have only women finishing it in 18 days. So total work on left hand side and the total work on the right hand side. Now the question says 4 days after they started the work, 4 men left. So very clearly for the first 4 days, 12 men and 18 women were doing the work. But after 4 days, 4 men have left. So when 4 men leave, there are only 8 men remaining. So these 8 men and 18 women will finish the work in how many days is the question there. To solve this question, we first need to establish the relationship between men and women from the given equation. 6 into 1 and 6 into 3 is 18. So we can say 12 men plus 18 women is 12 women into 3, that is 36 women. So when you take it to the other side, we get 12 men are equal to 36 minus 18, 18 women. Or we can say 2 men is equal to 3 women, since this is 6 into 2 and 6 into 3. So therefore very clearly the work done by 2 men will be equal to the work done by 3 women. Now from this we can find out the number of men in terms of women or the number of women in terms of men. For example, we can say that 1 man is 3 by 2 times 1 woman. That is nothing but the work done by 1 man is equal to 3 by 2 times the work done by a woman in the given time. Now let us try to frame the equation for the work done in the given case. Initially we know that 12 men and 18 women were doing the work for the first 4 days, and after 4 days 4 men have left. So very clearly for the first 4 days there were 12 men and 18 women. So the work done by them can be taken as 12 men plus 18 women into 4, since work is nothing but number of persons into number of days. And the remaining work was done after 4 men have left. So after 4 men leave the job, there are only 8 men left out, because 12 minus 4 is 8. So 8 men plus women as it is, 18 women, will do the remaining work in how many days? Let us assume the number of days required is D. So we are supposed to find out the value of D here. Now to solve this question, as I've already mentioned, we first need to convert the complete thing only in terms of man or only in terms of women. So let us try to take this only in terms of women. Now we know that 1 man equals to 3 by 2 times a woman. So let us use this in this equation. So we get 12 into 3 by 2 times women plus 18 women into 4 days, plus again 8 men can be taken as 8 into 3 by 2 women plus 18 women into the number of days required is to be calculated. Now by simplifying this, we get 6 into 3, 18 plus 18, 36 women into 4 plus, this is 4 into 3, 12 plus 18, 30 women into the number of days D. So this is the total work which has been finished only in terms of women, and we need to find out the number of days required by D. We also know that 12 women can complete the work in 18 days. So this total work can be equated as 12 women into 18 days. Now if you can see here, the whole equation is only in terms of women. So we can simplify this to find out the number of days D. So if we take 6 common, we get 6 into 6 is 36, 6 into 5 is 30, and 6 into 2 is 12. So very clearly 6 into 4, 24 plus 5D should be equal to 2 into 18, 36. So from this, D will be equal to 36 minus 24, that is 12 divided by 5. So we can say that the remaining work can be finished by the remaining people in 12 by 5 days, which is nothing but 2.4 days. So this is how we can use the concept of work in terms of persons into days to solve these type of questions. Remember friends, whenever we have a combination of different type of persons like men and women working together or men, women and children working together, it is always better that we convert the complete work only in terms of men or women or children, and then balance the work on both the sides to find out the number of days required. Let us now discuss the fourth example from model 3. The question here is, a father can finish a work in 8 days. After working for 3 days, his son joined him and the remaining work got finished in next 1 day. If son works alone, how many days will be required to finish the work? So as given here, father alone can finish it in 8 days. After working for 3 days, his son joined him and the remaining work got finished in next 1 day. So for the first 3 days, only the father was doing the work, and after that the son joins and the remaining work got finished in just 1 day. So we need to find out if the son works alone, how many days will be required. Now as discussed, we can always go for men into days concept for these type of questions where a person joins the group in the middle or he leaves after some time. Now here the two types of persons that we have are a father and a son. So we can say that the total work is nothing but father into 8 days, that is number of men into number of days. Understand, when we say F here, F is nothing but the capacity of the father or the efficiency of the father. So F into 8 is the total work, that is nothing but the number of persons into number of days. So only one person whose capacity is F into 8 days. Now after working for 3 days, his son joins him. So very clearly for the first 3 days only the father was working. So let's try to equate this work with the actual work done there. So for the first 3 days only the father was working. So the work done will be F into 3. And after that the son joins the father and both of them together finish it in just 1 day. So the remaining work got finished by father and son together only in 1 day. So by equating these two, we can establish the relationship between father and son. So that is nothing but the capacity of father and the capacity of son. So let us try to simplify this. Very clearly 8F is equal to 3F plus F plus S. Right, so from this, by taking this 3F plus F, 4F on the other side, we get 8F minus 4F, that is 4F will be equal to S. So we can understand that 4 times the father is equal to son, that is son's capacity is 4 times the father's capacity. Understand, this is a capacity equation, and here we are supposed to find out the number of days required if the son works alone. So here son's capacity is 4 times the father's capacity. In the beginning of the session we have discussed that capacity and number of days are reciprocal to each other. So if son's capacity is 4 times the father's capacity, number of days required by son should be 1/4 of the number of days required by father. So we can say that number of days for son should be equal to 1/4 of number of days taken by father. Number of days taken by father. And very clearly the father can finish the work in 8 days. So we can take this as 8. So number of days required by son will be 1/4 into 8, that is 2 days. So if the father can finish the work alone in 8 days, son alone will be able to do it in just 2 days. So whenever we need to find out the number of days required by any one of these persons, we first need to convert this capacity equation in terms of number of days equation. And that can be done with the help of simple concept that number of days and capacity are reciprocal of each other. So very clearly, if son's efficiency or capacity is 4 times father's efficiency or capacity, the number of days required by son should be 1/4 of the number of days required by father. So 1/4 of 8 is 2. That's how we get the answer here. Let us now look at another example from time and work based on the concept of men into days. The question is, 5 men and 6 boys finish a piece of work in 4 days. 4 men and 3 boys can do it in 6 days. In how many days 3 men and 6 boys will be able to finish the same work? So as discussed in the previous examples, again we simply need to balance the work in terms of men into days or persons into days. So here 5 men and 6 boys can finish in 4 days. So we can say that the total work done is 5 men plus 6 boys into 4 days. This should be equal to 4 men and 3 boys can do it in 6 days. So we can say that 4m plus 3 boys into 6. And the question is, in how many days 3 men and 6 boys will be able to finish the same work. So we need to find out the number of days required when 3 men and 6 boys will do the work. Now from this equation, let us first establish the relationship between the number of men and the number of boys. So 5 into 4 is 20 men plus 24 boys should be equal to 6 fours, 24 men plus 18 boys. Now by simplifying this, we can say that 4 men will be equal to 6 boys. Now with the help of this relationship, let us try to convert the given group only in terms of men or only in terms of boys. We know that 6 boys are equal to 4 men. So let us try to just substitute this in the given group. So 3 men plus 6 boys can be taken as 3 men plus 6 boys is equal to 4 men. So this is 4 men. So now the question can be read as follows. Instead of saying that 3 men and 6 boys will finish the work in how many days, we can simply say 7 men will do the work in how many days. So let us see how to get the answer here. Again, the same relationship can be used in any of these equations, and that can be balanced with this one to get the number of days required. So we know that 6 boys are 4 men. Now the first statement says 5 men and 6 boys finish in 4 days. So let us now use this equation in the first part here. So 5 men plus 6 boys can be taken as 4 men. So total 9 men can do it in 4 days. And we need to find out 7 men will do in how many days. Let us assume the number of days required is D. So 9 men into 4 days will be equal to 7 men into D. So very clearly from this we can say that number of days required by 3 men and 6 boys together should be equal to 9 into 4 by 7. That is 36 by 7 days. So that's how in all these examples that we have discussed from module 3, we can always go for the concept of measurement of work in terms of number of persons into number of days, and always balance the total work to get the required answer. Let us now discuss the fourth model from time and work, where the questions are based on efficiency. As we have already discussed, efficiency or capacity is nothing but the work done by a person in one day. And capacity is always the reciprocal of the number of days. So when the capacity of the first person is double the capacity of the second person, then the number of days required by the first person should be half of the number of days required by the second person. Similarly, if the capacity of person A is thrice the capacity of person B, then the number of days required by person A will be 1/3 of the number of days required by person B. So the only points which we need to understand here is capacity or efficiency is nothing but work done by a person in one day, and it is reciprocal of the number of days. Let us now look at the first example here. The question is 6 typists can do a piece of work in 8 hours. If 3 more typists whose speed is double join them, then the same work will be finished in how many hours? So as given in the question, 6 typists can finish a work in 8 hours. So very clearly 6 typists will be able to finish the given work in 8 hours. And now 3 more typists of double the speed join them. So 3 new typists will join them, but each of these typists can type at double the speed. That means the capacity of these 3 typists who are going to join is double the capacity of the earlier typist. So if the capacity is double, we can clearly understand that 1 typist of this second type can be taken as 2 typists of the first type. So instead of saying that 3 typists of double speed, we can simply say that there are 6 typists of normal speed. That is nothing but 3 typists who can type with double speed of double speed or double capacity are equal to 6 typists of normal capacity. 6 typists of normal capacity. So instead of saying that 3 typists are going to join, we can simply understand that 6 more typists will join. So 6 typists can finish in 8 hours. After these 6 typists join, how much time will be required? Now very clearly, when 6 more typists join, the workforce is getting double. Earlier we had 6 typists. Now when 6 typists join, the workforce becomes 12 typists. And when the workforce get doubled, that is nothing but when the number of persons are double, the number of days or the time required will be half. So here 6 typists can do in 8 hours. When 12 typists are there, the same work can be done in half of the time, that is 4 hours. So we can say that the answer for this question should be 4 hours when 12 typists are working together. Let us now take another example from model 4, which also is based on efficiency of the given persons. Let us look at the question first. The question here is, work done by A in 1 day is half of the work done by B in 1 day. Work done by B is half of the work done by C in 1 day. If C alone can complete the work in 7 days, then in how many days can A, B and C together complete the same work? So we are supposed to find out the number of days required when all the 3 persons A, B and C work together. Now if you can read the question here, work done by A in 1 day is nothing but capacity of A. As we have already learned that capacity is nothing but the work done by a person in 1 day. So we can see that capacity of A is half of the work done by B in 1 day. Again, the work done by B in 1 day is the capacity of B. So very clearly the first statement here is capacity of A is half of the capacity of B. If the capacity of A is half of capacity of B, then the number of days required by A should be double the number of days required by B, because capacity and number of days are inverse of each other. Now if you read the next statement, work done by B is half of work done by C in 1 day. So very clearly work done by B in 1 day is half of work done by C in 1 day. So again the work done by B here is nothing but capacity of B, and that is half of the work done by C, which is again capacity of C. So we can say that the capacity of B is half of the capacity of C. So again here the number of days required by B will be double the number of days required by C, because we know that capacity is inverse of the number of days. So if C alone can complete the work in 7 days, then in how many days can A, B and C together complete the same work? We know that C here takes 7 days. And from the second statement we can understand that capacity of B is half of capacity of C. So very clearly number of days required by B will be double the number of days required by C. So we can say that number of days required by B should be 2 into 7, that is nothing but 14 days. And from the first statement we know that capacity of A is half of capacity of B. So very clearly number of days required by A should be double the number of days required by B. So number of days required by A, let us take it as small a, should be 2 times the number of days required by B, which is 14. So 2 into 14 will be equal to 28 days. So very clearly we now know the number of days required by each of these persons, and we are supposed to find out the number of days required when all these 3 persons work together. So by applying the concept of unitary method, that is the work done by a person in each day, let us find out what will be the total number of days required. So when all the 3 persons A, B and C work together, we can say that the total work done by them in 1 day will be 1 by 28 plus 1 by 14 plus 1 by 7. Because number of days of A is 28, his work in 1 day will be 1 by 28. For B it will be 1 by 14, and for C it will be 1 by 7. So by simplifying this, we get 28 as the LCM. So 28 goes 1 times, 14 is 2 times, and 7 is 4 times, which is equal to 7 by 28 or 1 by 4. So very clearly the total capacity of all the 3 persons A, B and C working together is 1 by 4. That means in 1 day these 3 persons together can finish 1/4 of the work. So total number of days required should be equal to 4, as number of days is always the inverse of the total capacity or the total work done in 1 day. So number of days will be 4. So the answer for this question is 4 days. Let us now take the third example from model 4. The question here is A, B and C together can do a piece of work in 10 days. B and C together work thrice as much as A, and A and B together work 4 times as much as C. So in what time can each of them alone do the work? So here we are supposed to find out the time required when A alone, B alone and C alone does the same work. The first statement here is A, B and C together can do a piece of work in 10 days. So assuming that A takes A days, B takes B days and C takes C days, we can say that 1 by A plus 1 by B plus 1 by C should be equal to 1 by 10. This is nothing but the work done by each one of them in one day, and that is the total work which is done in one day when all three of them work together. Now the second statement is B and C together work thrice as much as C. So again, going by their work done in one day, we can say that 1 by B plus 1 by C should be equal to 3 times the work done by A. So 1 by A. And the third statement is A and B together work 4 times as much as C. So again, going by the one day concept, the work done by A in one day is 1 by A and by B in one day is 1 by B. This should be equal to 4 times done by C. So this can be taken as 4 into 1 by C. Now from these three equations, we are supposed to find out how much time is required by each one of them to finish the work. Now we know that 1 by B plus 1 by C is equals to 3 by A. So let us substitute that in this equation. So we can say that 1 by A plus 1 by B plus 1 by C is 3 by A. So 1 by A plus 3 by A should be equal to 1 by 10. So very clearly 4 by A is 1 by 10, and hence A should be equal to 40. That is nothing but 40 days. So the person A, when he works alone, takes 40 days. Now we can proceed to find out the number of days required by B and C. But friends, when you are doing this in the exam, remember at this step, you just try to verify from the options that which option has got A equals to 40 days. If there is only one option which says that A takes 40 days, we need not find out the remaining values. But anyway, let us now proceed to find out how much time is required by B and C working alone. Now again, using this statement, that is 1 by B plus 1 by A equals to 4 by C, in the first equation we can say that we know 1 by A plus 1 by B is 4 by C. So 4 by C plus 1 by C equals to 1 by 10. So again, by simplifying this, we get 4 by C plus 1 by C, that is 5 by C is 1 by 10, and hence C should be taken as 5 into 10, 50 days. So clearly C takes 50 days to finish this work when he works alone. So far we have got the values of A and C. So as I've already mentioned, always at each step you just try to check from the options. If there is only one option which says A takes 40 days and C takes 50 days, we can simply mark the answer and we need not worry about B. But here let us continue and find out the number of days required by B. Now by substituting the values of A and C in any one of these three equations, we can find out the number of days required by B. Let us substitute these values in the first equation. So we can say that 1 by A, that is nothing but 1 by 40 plus 1 by B plus 1 by C, that is nothing but 1 by 50 should be equal to 1 by 10. If you observe, we are trying to use this equation here. 1 by A plus 1 by B plus 1 by C equals to 1 by 10. And from this we can say 1 by B should be equal to 1 by 10 minus 1 by 40 minus 1 by 50. So by taking 200 as LCM here, we get 20 minus 5 minus 4, which is 20 minus 9, 11 by 200. So 1 by B is equals to 11 by 200. But we have to find out the value of B, that is nothing but number of days taken by B. So we can say that B takes reciprocal of this, that is 200 by 11 days. So the answer here is A takes 40 days, B takes 200 by 11 days and C takes 50 days. But friends, again I would like to mention the same point. If you do this question in the exam, it would be better if you verify from the options once we get any one of these values and try to eliminate the wrong answers. Let us now discuss the fifth model from time and work, which is based on people working on alternate days. Let us look at the question here. X alone can do a piece of work in 12 days. Y alone can do the same work in 24 days. If X and Y work on alternate days with X on first day, then how many days will be required to finish the work? So that's a very simple question where he says X alone can do the work in 12 days and Y alone will do the same work in 24 days. Now here we find that X and Y are working on alternate days, starting with X on the first day. That means on the first day X alone works, then on the second day Y alone works, again on the third day X works, fourth day Y works, and so on. So if we try to observe, the pattern here starts with X working on the first day, then Y, then again X, Y, and so on. Now going by the work done in one day, we know that X can finish the work in 12 days. So the amount of work that he can finish on the first day will be 1 by 12. Similarly, Y can finish the work in 24 days. So the amount of work that gets over on the second day will be 1 by 24. Again on the third day, as X is working, he can finish 1/12 of the work. So on the third day we get 1/12 of the work done. Again on fourth day 1 by 24, and this chain continues till the total work is over. So here we are supposed to find out the total number of days required. Now if you observe, the pattern here is of every 2 days. That means the work which is done in the first 2 days is same as the work done on third and fourth day, and which is again same as the work done on fifth and sixth day, and so on. So let us now understand how much of work gets over on every pair of 2 days. Now on the first 2 days we can find that the work that is over is 1 by 12 plus 1 by 24. So if you take 24 as LCM here, 12 goes 2 times and 24 once. So this is 3 by 24, which is 1 by 8. So very clearly 1 by 8 of the work is over in 2 days, because the first day work is 1 by 12, second day's work is 1 by 24. So 1 by 8 is done in 2 days. But we need to find out the number of days required to finish the total work. And total work, as I've already mentioned earlier, should always be taken as 1 unit. So if 1 by 8 is done in 2 days, the total work of 1 unit, this is the total work of 1 unit, will take how many days? Now as we know that work is proportional to the number of days, because when there is more work, more number of days are required. Less work, less number of days are required. So we can simply cross multiply this and find out the answer. So we can say that the number of days required when X and Y work alternatively will be 1 into 2, that is 1 into 2 divided by 1 by 8, which is equal to 16 days. So our answer here should be 16 days. So friends, this is how we can solve questions related to people working on alternate days. The only thing which needs to be understood here is the correct pattern which repeats itself at regular intervals. Let us now look at the sixth model from time and work, which is based on the distribution of wages. That is nothing but the amount which a group of persons receives when they do a work together. So here we need to find out the individual shares of the persons. Remember friends, always the distribution of the amount should be done in terms of capacity of the persons. That is nothing but we should find out the capacity of each of the persons, and accordingly the amount should be divided among them. Let us look at the question here. A can do a piece of work in 15 days and B in 20 days. They finished the work with the assistance of C in 5 days and received rupees 45 as their wages. So what will be the share of each person? So as we can see here, the total amount which the 3 persons got is rupees 45, and we need to find out the individual share of these persons. As I've already mentioned, amount should always be divided based on the capacity of each person. That is nothing but the amount of work which they can do in 1 day. Now the first statement here is A can do a piece of work in 15 days and B in 20 days. So very clearly the amount of work done by A in 1 day will be 1 by 15, and that by B will be 1 by 20, because the number of days required by them are 15 and 20 respectively. Now we also need to find out the number of days required by C alone to get the answer for this question. So let us look at how to get the answer there. The next statement here is they finished the work with the assistance of C in 5 days. That means A and B together with the assistance of C. That means all the 3 persons now are working together and they finished the work in 5 days. So very clearly 1 by A plus 1 by B plus 1 by C should be equal to 1 by 5. So we can say that 1 by A plus 1 by B plus 1 by C should be equal to 1 by 5. So we can say that 1 by 15 plus 1 by 20 plus 1 by C is equals to 1 by 5. So from this 1 by C will be 1 by 5 minus 1 by 15 minus 1 by 20. The LCM here is 60. So 5 goes 12 times, 15 goes 4 times, and 20 goes 3 times. So 12 minus 7 is 5 by 60, which is nothing but 1 by 12. So very clearly, the work done by C in one day is 1 by 12. So we can say that the capacity of A is 1 by 15, the capacity of B is 1 by 20, and that of C is 1 by 12. The capacity here is nothing but work done by each person in one day. So we can say that the ratio in which the amount has to be distributed among A, B and C here is 1 by 15 is to 1 by 20 is to 1 by 12. That is capacity of each of these persons. Now to simplify this ratio, let us multiply the whole thing with 60 so that we get a proper ratio. So 60 divided by 15 will be 4, 60 by 20 will be 3 and 60 by 12 will be 5. So this is the ratio in which the total amount of rupees 45 is to be divided among the three persons A, B and C. So A is to B is to C, we will get the shares in the ratio 4 is to 3 is to 5. So now using the concept of ratios, we can say that the amount that A gets will be 4 parts out of total 4 plus 3, 7 plus 5, 12 multiplied by the total amount which is 45. Similarly, B gets 3 parts out of total 12 parts multiplied by 45 and C gets 5 by 12 into 45. So 4 by 12 is nothing but 1 by 3 and 1/3 of 45 is 15 rupees. So A should get 15 rupees. Then 3 by 12 is 1 by 4 and 1/4 of 45 can be taken as 11.25 rupees. That is 11 rupees 25 paisa. And then the left out amount should go to C, or we can say 5 by 12 into 45 is the amount with C. So 15 plus 11.25 rupees is 26.25. And total amount 45 minus 26.25 will be equal to 18.75 rupees. So we can say the amount with C should be 18.75, or we can simplify this part to get the answer. So these are the individual shares of the three persons among the total amount of 45 rupees. So friends, remember only one point, that the amount or rupees always should be divided in this case based on the ratio of their capacities or ratio of the work done by each person in one day. Let us now look at the last model from time and work, which is based on pipes and cisterns or pipes and tanks. This model on pipes and tanks is completely similar to what we have discussed in time and work. Here we have got a water tank with different pipes which are used to either fill the tank or to empty the water from the tank. And we need to find out the total time required when different combinations of pipes are working together. Let us look at the model here. We have got two different cases. Let us first understand the case one. As you can see here, we have got a water tank with two pipes, pipe A and pipe B. Both the pipes here are inlet pipes. That means both these pipes are used to fill the water in the tank. Now when pipe A is running alone and pipe B is closed, the tank can be filled in A hours. And when pipe B is running alone and pipe A is closed, the same tank or the same cistern can be filled in B hours. So we are supposed to find out how much time will be required when both the pipes are running simultaneously. Now if you try to observe here, this is completely analogous to what we have discussed in case of time and work. There we have different persons working together, and here we have different combinations of pipes working together. For some time, let us assume that pipe A is nothing but a person who can finish the work in A hours, and pipe B is another person B who can finish the same work in B hours. Now as we have discussed earlier, whenever two persons are working together, we can go by the unitary method, that is the work done by each of the persons in one day, or we can apply the direct formula, which is AB by A plus B. So here again we have two pipes which are working together and their work is to fill the tank. So we can say that the work done by pipe A in 1 hour will be 1 by A, and the work done by pipe B in 1 hour will be 1 by B. Since both the pipes are working together and they are filling the tank, we can say that in each hour the total work done will be 1 by A plus 1 by B. So this is nothing but the total work done by both the pipes in 1 hour. Once we get the total work done by both the pipes together in 1 hour, we can take the inverse of this to get the total number of hours required to fill this tank. So this is nothing but time and work in a different way. Here we have pipes working together instead of persons working together. But one special case that we have here is case number 2. Now as you can see here, we have a water tank which has got two pipes, pipe A and pipe B. But the difference here is, in the previous case, both the pipes were inlet pipes. But in this case, pipe A is an inlet pipe which is used to fill the tank, but pipe B is an outlet pipe. That means this pipe is used to remove the water from the tank. When pipe A works alone, it can fill the tank in A hours. But when pipe B works alone and pipe A is closed, the same tank can be emptied here in B hours. So we need to find out the time required to fill this tank when both the pipes are working together. Now here if you observe, our job is to fill the tank and pipe A is used to fill the tank. So we can say that pipe A is doing the correct work, but pipe B is removing the water from the tank, which is against what is required. We have to fill the tank here. So we can understand that pipe B is doing the wrong work or the opposite work. So in one way we can say that A is doing positive work and B is doing negative work here. So to find out the total time, again we need to go by the 1 day's work concept, but with a slight difference. The difference here would be the work done by pipe A is 1 by A as in the earlier case, and that by pipe B in 1 hour will be 1 by B. But we need to take a negative sign in between them. Why? Because B is doing negative work. So we should take minus 1 by B. So 1 by A minus 1 by B is the total work that is done by both the pipes together in 1 hour. And once we get this value, we can take the inverse of this to find out the total time required to fill the tank. So this is the only special case and different case that we have when compared to time and work. Otherwise, all the questions from this model of pipes and cisterns can be solved simply by applying the concepts that we have discussed in time and work. So there we have learned one concept called men into days or men into hours. Here we can apply the same concept as pipes into the hours or pipes into time. And all the remaining concepts are applicable here. Let us now look at the first example from pipes and cisterns. The question here is, pipes A and B can fill a cistern in 10 and 12 hours respectively, and pipe C can empty it in 6 hours. So if all the three pipes are opened simultaneously, then how much time will be required for the tank to be full? So as you can see here, we have got three pipes where pipe A and pipe B can fill the tank in 10 and 12 hours, and pipe C can empty the same tank in 6 hours. And we are supposed to find out the total time required when all the three pipes are running together. Now, as discussed earlier, whenever a pipe is used to empty the tank, we should consider it to be doing the negative work. So here, going by the unitary method or the work done by each of the pipes in 1 hour, we can say that the work done by pipe A in 1 hour will be 1 by 10, plus the work done by pipe B in 1 hour will be 1 by 12, minus the work done by pipe C in 1 hour will be 1 by 6. Remember, we are taking a negative sign here because pipe C is used to remove the water from the tank, and hence it is doing opposite work. So we take it as negative work. So the total of these values will give us the total work done by all the three pipes together in 1 hour. So by simplifying this, we can say that the LCM is 60 and 10 is 6 times, 12 goes 5 times and 6 goes 10 times. So 6 plus 5, 11 minus 10 is 1 by 60. So very clearly, when all the three pipes are running together, 1 by 60th of the work is done in each hour. So we can say that the total time required will be reciprocal of this, that is nothing but 60 hours. So friends, as you have observed, this is quite similar to what we have discussed in time and work. The only difference is there we have different persons doing the work, and here we have various pipes which are used to either fill the tank or empty the given tank. Let us now take another example from pipes and cisterns where we shall use the concept of work in terms of men into days. Or here we can say that the work can be measured as pipes into time. Now, the question here is, a water tub can be filled by 2 taps in 8 minutes. One tap is closed after 3 minutes. The other tap fills the remaining tub in 15 minutes. How much time the faster tap will take to fill the tub alone? So here, as you can see, we have got 2 taps which can fill a water tub in 8 minutes. Let us assume that the 2 taps are A and B, and the time taken by them is A and B respectively. So one tap is closed after 3 minutes, the other tap fills the remaining tub in 15 minutes. So very clearly, for the first 3 minutes, both the taps were running together. And after 3 minutes, one of the taps is closed. And then the other tap fills the remaining tub in 15 minutes. Let us now try to use the concept of work equals to many into days, or in this case, work equals to the pipe into the time to solve this question. So here we can say that work can always be measured, or work done can be taken as the pipe, the particular pipe into the time for which it was open. Now, as the water tub can be filled by two taps A and B in 8 minutes, we can say that the total work is A plus B into 8. That is nothing but both the pipes are working together for 8 minutes to fill the water tub. So total work is A plus B into 8. Now this should be equal to, as given in the question, one tap is closed after 3 minutes. So very clearly for the first 3 minutes both the taps were working together. So for first 3 minutes we can say that the work done is A plus B into 3, since both the taps were working for first 3 minutes. So this is the amount of work done in first 3 minutes, and after that one of the taps is closed. Let us assume tap A is closed, or we can also assume that tap B is closed, but let us go by tap A is closed. So when tap A is closed, the other tap, that is nothing but tap B here, can fill the remaining tub in 15 minutes. So the remaining work was done by pipe B alone, or tap B alone, in 15 minutes. So this is the work equation, that is nothing but in terms of pipes into time. Now by simplifying this, we can get the relationship between the two taps. So by taking A plus B into 3 on the other side, we get A plus B into 8 minus 3 is 5, and that should be equal to B into 15. So 5 into 1 and 5 into 3 is 15. So from this we can say that A plus B equals to 3B, or we can say A is equals to 2B. That means the tap A is twice the tap B. Now as already discussed, this is nothing but the relationship between the capacities of the two taps. That means the capacity or the efficiency of tap A is twice the efficiency of tap B. That means tap A is the faster tap here, which takes less time, and tap B is the slower tap. Because tap A can work twice as fast as tap B, it is obvious that it is the faster tap and it takes less time. So this is the capacity equation of the two taps, capacity or efficiency equation. Now from this, very clearly, if tap A is twice as fast as tap B, the time taken by tap A should be half of the time taken by tap B. So we can say that time taken by A should be half of time taken by B, because capacity and time is always reciprocal to each other. So because the capacity is twice, time should be half of tap B. Now we need to find out how much time the faster tap will take to fill the tub alone. The first statement here is the water tub can be filled by both the taps in 8 minutes. That means the equation will be 1 by time taken by tap A plus 1 by time taken by tap B should be equals to 1 by 8. That is nothing but the work done by each of the taps in 1 minute. The given question says how much time the faster tap will take. Very clearly the faster tap is tap A. So we need to find out the time taken by tap A will be equal to what. So to find out the time taken by tap A, let us substitute the time taken by tap B in terms of tap A. So we can say that time taken by B will be equal to twice the time taken by tap A. So by using these two equations, we can find out the required answer. So I can say that 1 by time taken by A plus 1 by time taken by B is nothing but twice the time taken by A, which is equals to 1 by 8. So from this we can say that the LCM is 2 times the time taken by tap A. So 2 plus 1 equals to 1 by 8. 2 goes 4 times, and hence time taken by tap A will be 2 plus 1, 3 into 4, 12 minutes. So friends, as you can see from these two examples, the questions from pipes and tanks can also be solved simply by using the concepts that we have discussed in case of time and work. That's all from time and work. See you in the next session. Thank you.